Hello and welcome to my new tutorial. I, I wasn't planning to do this, but I was asked by a junior artist about how would I approach something like this. I was asked this question because of my vines tutorial from 2 years ago. And while I had this never finished project where I do something very similar, at least somewhat similar, I decided that might as well bring it to the state where can be shown and explained. I apologize ahead of time for some mouse clicking or keyboard clickings. Nothing much I can do about it with my microphone standing right on my desk. Also, accent, I guess. So yeah. All right, let's get to it. So this is one mesh, vines mesh, that was built taking into account the model that it needs to be wrapped around, just like in the required task here. I was also asked about potentially doing it as HDA right in Unreal Engine, and while it's often a good idea when it comes about vines or some structures that are repeatable multiple times, in this case, with a lot of merging and remeshing, I don't think that it makes much sense to do HDA. And also, this is kind of like one-time thing, one-place thing. I mean, it cannot be placed as it is on something else. It would not look natural. And there could be other approaches, like making it modular, maybe. But in this case, the question was, I mean, in my case, I needed this specific one mesh. So I don't think that HDA would work good. So I think that it should be just one, yeah, just one piece, and let's get to it. So what I did, how I started planning it. Oh, and also one more thing. The artist is a junior artist and specifically asked me about my thought process. So this is tutorial intended for beginners. I will be explaining in details exactly why I'm doing what I'm doing. So there'll be no much for anybody who has more experience with Houdini. So yeah, this is the beginner tutorial. Don't be mad if I get into too many details. Right. So with this done, let's get to it. So what I start with. So this is my scene, right? And I want this guy, the Buddha head, to be wrapped around some tree. So what do I do first in case like this is I create meshes that are like a block out. Ah, okay, they're invisible in game. So yeah, a block out of the structure, at least of the the main shape of the structure that I want to create. And I gave it material that I will not need anywhere else, so it will be nicely visible, and also it will be easy to separate in Houdini later. And those are just splines made in Blueprint. So let's look at the blueprint first. All right, so on construction script, we do this on construction script, not in event graph. So first I create a new blueprint. It's just standard actor blueprint. I add spline in here, spline component. And here I do some things like I make a new, so I pull the spline here. So this is my component, using component, I get it lengths. I get section lengths. It's just two variables, two float variables. Just click plus and make new float and give it names. It's not necessary to work with widths, but I use this type of tubes for other purposes. That's why I prefer to have length and width set up. So here, nothing much to explain. I divided the lengths by the lengths divide the spline by the length of the section, truncate it to have an integer. And here I do add, so I start the loop, and in the loop I add static mesh, spline mesh component, the cylinder that I will be bending. And this is just the usual normal small static mesh. Actually, the material applied to it. It's just the cylinder that I made in Max, I think. It was long ago. With some subdivisions. Like, it doesn't matter here. It just needs to be, it needs to have enough subdivision to be easily bendable. It will be eliminated. It just needed for Unreal to be able to bend this mesh around. So I am adding the spline mesh component. I'm setting forward axis. In my case, it's Z. Actually, normally it's X. I don't know why I have Z here. Also, the collision is not needed here. And also, then I set start and end for the spline mesh component. Here we use get location and distance along the spline for beginning and for the end for each point. So yeah, so this is the, like, each section, the beginning of the section and the end of the section. So we have index of the loop +1. Here I clamp the vector size. So it just, I'm trying to just not drag this for too long. Set start and end, and also I set scale. That's why I have the section width variable. So I set start scale and a set end scale, and so each section goes through the loop, and we have as many loops as we need based on our length of the spline. So yeah, both variables are open for editing, instance editable. And that's why when I go to my scene, when I start a new blueprint, I can adjust the length and width, and you will just, if you will repeat this blueprint, you will have some based on your cylinder and based on the scale of your scene. And because you can see my scale is pretty high. This lady is about as tall as I am, so 5'7". So those are my numbers. It can be whatever in your case. And so, but from this, I just bend. Let's see. So let's imagine that I have a new. Yeah, see, my cylinder is pretty huge. That's why it's such a, and also scale is big. Okay, scale to what it was, 200 length. All right. It's too small of the spline. And just drag a spline, and if you need a new point, right click in a spline, add spline point here. And that's how you do it. And then you just bend it around the way you need it. So also, when you're doing this, by the way, good that this happened, try to avoid this, because if this happens in Unreal, then it will be more difficult to process in Houdini. So in order to avoid more work in Houdini, just make sure that you don't have this twisted parts. So I don't know why it's so hell-bent on being twisted. Others actually didn't do that. So let's say now we have our splines, 4 of them. I decided also, like, thinking ahead, if it's going to be a tree, then I might as well make one of the splines a little bit longer, that I will use it as a basis of the tree, which is, where is it? Which is here. So yeah, that's why that's the reason why one of the splines is longer than the others. After I'm done with this, now we need to bring the splines and the mesh, and also, just in case, the landscape in Houdini to work with it. Also, here I have my cubes that I used as just to block out meshes, and I'm going to use cubes for the collision meshes, not the the final shape. It's just because those have too many polygons and the pretty much shape is pretty much the same. So I'm gonna just use the just simple geometry, Unreal geometry, but I will bring actual head. One problem here is that there are two ways of export stuff. I mean, two ways that I'm usually using to export stuff from Unreal. When it comes to splines, you cannot just go to File and Export Selected. They will not work. You need to merge them. When it comes to landscape, you cannot do otherwise. You cannot merge it. You need to export it. So what I'm going to do is select my collisions first. It's all cubes. Head. Oops. All cubes. Shift. Control head and control all my splines. All right, when I selected all of them, I go to Actor, Merge Actors, Merge, and I already did that, so I already have this actor here. So if you select it to override it, you need to erase the beginning of it, because it will add SM on its own. So if you want to reuse this one, just erase the beginning. So save, and I have a new, which is, in this case it's the same. I have a new mesh here. Now from here I go right click, Asset Action, Export, and I just choose where to export it. I'm not gonna do it right now because I already did it, but yeah, just select where you want it. Now with the landscape, in order to make sure that everything is aligned in Houdini later, I select landscape and the head, so I will have the anchor point later on. And from here I do File, Export Selected, and again export this FBX, and then later bring it into Houdini. So this is what we need right now from Unreal. So let's jump into Houdini. Here I have everything set up, a little chaotic, but don't worry, it'll be good. So here I use File node, and I bring my vines, which is these ones, and also I bring my landscape. And also right away I add transform node and do a scale 0.01 because Unreal has units centimeters and Houdini has meters. So we need to scale everything down to have proper size in Houdini. So my cave vines and my landscape with the head. And you can notice right away that we have a problem here. They are not aligned. For some reason they just export it. I don't know why it is what it is, but that's why I bring something in both of them to be able to align them later. Now I go and create a group from my head, which and while I know that I have different materials set up and materials are exported, yeah, I just know that my Buddha head has material and my Buddha head, and I know that it's unique. That's why I might as well create a base group based on material name. And so you see that here's my actor, and my group is named anchor. Here I do the same. I create anchor, and now I can match my landscape, and I decided to use this one as the correct one. And so I need to align my landscape with this one. So I use match size node, and I put landscape into the first pin, what is going to be aligned, because the second pin is what is going to be aligned to. And also here I check use groups to determine justification bounds, and I use anchor because there are anchors in both. So I'm letting match size node know that I'm using anchors to compare which is where. And after this, as you can see, the landscape is getting moved right where my original vines shape is. And so after I did that, now I do not need a Buddha head here anymore, and so I just delete it from here. And so I only have a landscape which is now aligned. And now I merge both of my actors to finish my setup, and I also match size it, again using my Buddha head as anchor to so I set up a Y in minimal, so its bottom will be aligned to the 0 in Houdini. In this case, it would not be really necessary, because as you can see in Unreal, while it was like a cave scene, my Buddha head is almost at the 0 of coordinates, 0, 0, 300 up. But if in your scene your object are somewhere far away from the center of the scene, they'll be exactly that the same way as it will be imported into Houdini. So usually it makes sense just to bring it all to the center. And also the second benefit of this is when I bring my tree into Unreal later, I can give it the same location as the Buddha had, and it just matches. So it just makes it convenient. Right. So now after I aligned the head to 0 coordinates, now I can split what I'm going to be working with, and I'm splitting. Remember I said that I was using this weird material that nothing else uses, the red one, anim share in red. So that's what I'm using here to just split my splines, what I'm going to be working with. And I'm cleaning all the attributes and groups, because FBX brings a lot of attributes with it that FBX, a file import that we do not need. So I remove all of this. And the same here. I bring here landscape and collisions, and I separate landscape by the name, and I have my original shape separately. And I add null nodes without caps names to be able to quickly find them when I need them later. So, okay, let's work with our splines now. If you check the original Unreal splines, you can see that they are the cylinders that were wrapped around those splines. They are actually separated. It's not merged. They are separate meshes. So all the seams have duplicated points in them. So I'm fusing it first to have all the point numbers just singular. And also I add connectivity node, which you can also do this for each loop, for each connected piece. So this is basically what I started this big chunk with. So connectivity allows to give each connected primitive separate class. And if you see the class here, preview the class attribute, you will see that they're all separated. I always recommend to check it, because I don't know, just in case. They should never be crisscrossed, but just in case. So this was for each loop, and now we separate each single one of them, and we need to actually extract the splines, the underlying splines from the cylinders. How do we do that? So the way that I'm doing this is first I polyfill it. So I just fill it with one single polygon, and I also check patch group to have those polygons in a separate group, so I'll be able to easily split them. Then I remove everything except those patches. So I only need the caps, because I only want to have up cap, the top capped. So I need to separate it. Then I select bottom, and I do the group by bounding region, because there can be 101 way to separate the groups, including like manually, or but depending on the size, I just decided, and depending on the location, like what if you don't move it to the center? So I move it to the bottom of my mesh, which is just these two, like it's pretty tall right now. So I move it to the bottom by using this formula, bbox y minimal. And I have a huge size, and also I check, just in case, include partially contained entities. And while it's a single polygon, I have a good chance that it will be affected. And then I blast it And so now I only have the top polygon remaining. And after that, I merge it with the original spline and I fuse it back. And now I have my spline, my tube with hollow bottom part. And you will see why in a minute. So what I do now is I do another loop, which is for loop, just for loop with feedback. This one. The good thing about this loop, unlike this loop, so this loop goes extracting pieces or points. In our case, it's pieces separated by class attribute, because that's why we use connectivity node to give each of the cylinders different class. So we have from 0 to 3. And so this for loop goes through our classes. So it will go 4 times. You see it here. Loop with feedback goes as many times as you want it to go. And here you set up whatever amount of iterations you need, and it will go as long as you need it to go. So this is the loop that I'm using here. So I'm starting it. This is the final stage. So to go back to the stage 0, I need to go to iteration 0. And also sometimes if it doesn't update, you need to do reset cached pass. So this is how it started. First, I identify the edge, and that's why I needed the cap on top, because here I use points and I include by edges unshared edges. I needed just one unshared edge, and that's how we got it. So I identify the edge, I polyfill it again with one single polygon and again with patch group. Then I extract this patch, and then I do extract centroid. So I need a point of this, like point in the center of this shape. Usually it's actually center of mass, but you might need to try to also the main thing that you need to do is to switch to primitives, because here we have one primitive. That's why it was important to just use single polygon. And so yeah, we extract the point in the beginning of this, in the center of this little shape, circle. And also from here, I do another thing. I kill this edge. I blast it. So I blast the edge, and then I merge remaining tube with blasted edge, and also it already has the first point. And then when I go through my iterations, you can see that in each iteration, it does this, removes the edge and replaces it with a point. And so I do, I guess 150 iterations will be enough here, but it might be as many as you need. And after I'm done with this, for each tube, so inside of this, so we started from the tube, we ended up with just points in the middle of the tube, and then we use the add node just by group, and we have spline back. And when we're done with all 4 of them, we have our 4 splines extracted. Then I sort them by vertex order, and I also revert them because I want them to start on the bottom of the mesh, not on the top. As here, like you see, the point numbers go from top to bottom, and I just want it reversed. And also to have it applied to vertices, not just points, we use polypath node, because if you don't use it, you will keep the same order. This is important to know, by the way, because here we use vertex order, and if we sort points, not vertices, which are underline this. If you press D and you go to vertices and you do like markers or numbers, oops, numbers, you can see vertex numbers, not just points numbers. And so here we sorted them, we reversed it, and after polypath, it's kept reversed. So D and remove this. All right. Now after that, we just resample it to have less. Oh, no, okay. Here I'm not resampling it to have less points. And by the way, I can undo class. I guess I need to do it where I do have class. Oh well. Let's just continue, I guess. Right, resample. Resample, I do resample just to extract a curve view attribute, which starts from 0 and goes to 1, given each point the attribute. Yeah, from 0 to 1, no matter how long the spline is. Then I do group by range because I need top points. Group by range, don't forget to do affect disconnected geometry separately, so each spline will have its own first point. In our case, it's the last point. And also I do invert to have our end selected, just 1 point. And I only do that because I kind of want to bring them together. They're kind of too messy right now to look like a tree trunk. So here I use soft transform node. I only select top points. And what transform node does, it's here I just want to just squish them together. So I use a very, very small scale, and I go I'm just increase. You can see how it merges. I just increase the radius of the effect, so from the very top, and in my case 15 meters look like a good way to deal with this. And also after I'm done with this, I do attribute remap. That's why we created curve view attribute, to know the lengths of the spline, to give each point along the spline it's like measure its position on the spline. And now we convert it into p-scale attribute, which we will need later for us for our to actually make our shape of the trunks. Let's see what it's doing here. So if we stick it into the sweep node and use a round tube with radius, let's say 1, here you see that we take our curve view, we move it into, we create attribute p-scale, which is default Houdini attribute, setting up the scale of the let's say of the spline here. And I use ramp. So where curve view is 0, our p-scale will be 0, and it goes to 1 becomes 0.9. And also I use the curve to have them kind of thinner in the beginning and the end, and kind of thicker in the middle. Maybe here it will undo it. Yeah, that's interesting. Didn't have that before. All right, so this is why we do curve view attribute. Now let's see how we're gonna try to make these splines kind of wrap around our collision to kind of follow the shape better. So first what I'm gonna do here is I take my original mesh that I extracted here in the beginning. I take my mesh, I convert it to VDB so by the node VDB from polygons, with just the voxel size. It's just arbitrary. I just looks good enough. Yeah, works. If it will be much smaller mesh, a much smaller scale, I would have to make a voxel size smaller. But in this case, it worked. And after I did it, after I converted into voxels, I converted to polygons again. And now, instead of having this mass of crisscrossing objects, I have one single object. And also, what I do here is I'm making it a little bit larger. You can see that it's let's do this. You can see that it's a little bit thicker than my original mesh. I do this so the while I am aligning wrapping the splines themselves, but splines later will have thickness when we will add the sweep node. So, so even the smallest splines will be sticking to this outer shell, not the inner one, and so they will not be actually intersecting with our normal geometry. Again, the scale here is arbitrary, and I deemed this one good enough. Also, what I do here is, I know that I only want my things to be wrapped around the head, so I use the box node to just around my mesh, and I make it larger because, like, who knows where my splines would be, where they would be. Like here, you see that if they will be just around the head, they would not the whole thing will fit into it. So might as well make it huge in width and height. And also I made it a little bit smaller, so it will not be just with the height of the head itself. It will be just a little bit lower. And what I do here is, again, I start another for loop to work with each spline separately. And here we have our splines, right? And oh, actually, no, hold on a second. It's a feedback loop. So it's a loop where I have iterations set up manually. So I'm sorry. This is the same as this one. So I use all my splines. I use a group node to select only the parts that I want to be wrapped around my head. And so this is my mesh. This is, let's look at the head better. Oops. Okay, so those are the points that I want to be wrapped around my mesh. And that's why I use select points in a bounding region, and I use the convex hull, or I can do bounding object. It doesn't matter here. Actually, it does matter a little bit, which is weird because it's a box. But yeah, okay. So then I delete okay, I delete any points if there will be, because in one of my earlier tests, one of the points was inside of the head, and so I just select the points that are inside of the head itself, if it just happened, and I just delete them to have clean geometry, the clean splines to start with. So now there is nothing selected here, and that's why there is nothing to delete. And what I do next is I use ray node, where we stick our points to be projected onto something, into first input, and the actual primitives, the collision that it needs to be projected to into second input. I use a minimal distance method, and I use only group stick points, so only the points that were selected here are being transferred into being moved in the ray mode. And I also use lift minus 0.8. So if you use the standard lift 0, they will try to stick to the closest point on a collision mesh. But I do not want it. I want them to be close to my head, but not stuck to it, because again, they will have thickness. And also I do a little point jitter for them not to be as straight. And then I do resample with length 1 meter. It's a huge mesh. And also I use subdivision curves, so my splines would be smooth. If you see, if I do straight edges, they just resample, and with subdivision curves, it just makes it a little bit smoother. And so I do this 3 times. And it looked like, to me, like satisfying enough result to begin with. And so from here, I made a sweep. This is like my test sweep to have my main roots. It's pretty rough right now, but it's a beginning, and they already more or less aligned with the head. They're already stuck to like whatever geometry we need them to be stuck to. So from here, I do another connectivity node to have each spline separated. I don't know how to. Yeah, I don't know what happened here. All right, here we begin a very big standard for each loop by class. So for each connected piece, that was the one. And from here we will work with each spline separately. So what I'm doing here in this big loop, I'm adding those secondary branches from this from each spline that will reach to the ground, to our landscape, and later we will work with them, with those secondary branches. So first, what I'm going to do is, I do not want secondary branches to be all the way from the very top, because we definitely do not want the, I mean, if you even look at our references, you see that at some point those secondary roots just stop coming. They just merge into one shape, like one tree. And again, it depends on your references, but in this case I decided that my trunk will start about this area. So first, what I want to do is I want to carve, so make this shape smaller, to limit the areas where the secondary roots will be created. And to do it randomly for each of my shapes, I decided to do, again, here I use just four splines to begin with, but what if I had more? And to introduce randomness, I'm using this formula. So basically what happens is, first I clicked here and I created create meta import node, which created this node, and I just renamed it for each spline for my own easiness. It's much longer. What's the name? Yeah, so if you can see it, it just gives some weird long name by default. So I just made the name myself. Right. This metadata loop, it will what it will do, it adds in our details. If you go into details attribute for our loop, you can see that each iteration will have its own ID. So we have overall 4 iterations, and each one has its own ID. And if we go to our last and we do single pass, so let's say our first spline is pass 0, and you can see that our metadata node gives us iteration 0, and on iteration 1 it will notify us that it's iteration 1, and that's the way how you can access the information about which loop we are dealing with. And also you can use random node to, like, you can use that as the base for the random node, and that's exactly what I'm doing here. So I do random node based on this. So this is the part here we access our metadata. So detail, this is just a formula where you can which you can use to access any detail information. So this is the detail attribute, iteration 3 in this particular case. So detail, the name of the node we're addressing, it's this one. Then the name of the attribute we're addressing, it's iteration, and then if the ID of the attribute, because sometimes like attribute like P or N, so like position or normal, it has more than one dimension. Iteration is just has one dimension, but you still need to point specifically at which dimension you are addressing. You cannot skip it even if it's just one dimension. So we address our detail attribute, our iteration number, and we use it as a base of random. But random function gives us a random value from 0 to 1. But that's not what we want. We want to manually specify how much we want to carve of our spline, and carve node just cuts the percentage of the spline. So from 0, like you can see, from 0 to 100%, from 0 to 1, so from the beginning of the spline or from the end of the spline, depending on what are you carving, which side are you carving. so I want to carve from the top something be in between from 0.6 to 0.8. So this is our like the end of the spline. So we want it to be done on any distance from 0.6 to 0.8. And so that's what I do here. I use fit function, which I feed 0, 1, which I feed our results of the random node, and then I put a comma, and then I specify. So 0 becomes 0.6, 1 becomes 0.8, and so this node returns me a value between 0.6 to 0.8, and it's like a bell curve. So mostly your numbers will be somewhere in the middle, somewhere around 0.7. And of course, the more numbers you have, the more variety you will have. So sometimes, like even if you think that you need something narrower, you might as well want to put wider range of the numbers, because most of them, they will be in the middle anyways. So that's the carve. So I'm cutting off the top part, and I'm cutting off a little bit in the bottom. So I would not have secondary roots showing up in the very bottom of my mesh, because it's not necessary. They're basically in the ground here. Then from here, so when I cut my spline, here I just make random points with arbitrary percent, depends on what we want, and I blast all of them. I blast everything but them, and with add node, I just remove the spline, and I keep delete geometry, but just keep the point. So I only keep the points that were selected by this node. And what I do here is I add a enumerate node to give each of these points the index, the ID, and specifically to the points. So now each point has its own unique ID, which we will need later. And also what I do here is so if you remember, here we gave each point in our spline here received its p-scale attribute. So we already have a thickness at each point of this of the spline. When we separate our points from our splines, they still remember their own p-scale attribute. So each one of them, if we add, if there was still spline, each one of them would be having the same thickness as the spline here, the same scale. But when I'm working with secondary roots, I want them to be a little bit thinner. So let's say that the secondary root will come into our trunk. Let's call our base splines trunks. Will come into our trunk in this point. We want it to be a little bit smaller than the trunk. We do not want it to be the same width as the trunk. I don't want in this case. That's why I do this. So I use this formula. I multiply p-scale by 0.6, so I make it a little bit smaller. So each one of them, each point will have its p-scale reduced, and each one of them will have it here. You see this attribute. So what I do next is right. Okay, let's look at our collision where we want our points. So our roots will start from here. Now where we want to end them, and here I use my collision, the one that I created before. It's remeshed. It has just one continuous polygon. Oh, by the way, here, if you do this, and let me show you quickly what I mean. If the mesh is open, let's say this, and I want to do VDB from polygons from this mesh, it will not work. It will not work because for this to work, the mesh needs to be continuous, or at least it needs to be able to fill it up. So the best you can do if you're working with open mesh, let's say like here, you need to polyfill it. Even if it's going to be very dirty, it still needs to be something. And in cases like this, I would recommend to try quadrilaterals. Usually do not work. So simple polygons, single polygon has better chance of working, and still it didn't. So yeah. What you could do, like if it was really something similar to this, you would need to like separate the head and then polyfill the head, and then the rest of them without head, maybe they would be actually covered nicely. So separated head would work with single polygon. Let's demonstrate it. I don't know why I'm doing this. It's not necessary at all for the purpose of today's video, but I guess for the sake of less experienced artists. Okay, and non-selected, and then polyfill. No, I deleted too much, I guess. All right, never mind. So there are ways to do this, but yeah, the mesh needs to be continuous. It doesn't need it cannot have holes, or at least cannot have big holes. So we have our collision. Here I clip it, and to clip it at the very bottom, what I do is I use for my origin, instead of 0, I use the very minimum of my mesh, and distance by default is 0, and also direction is 1 in Y, meaning that we go vertically from bottom to top. -1 will go from top to bottom. So, and here I use the base, so the lowest point of my mesh, I use it as the origin of my clipping. That's why with 0 it's not clipping, because it's this clipping plane is at the very bottom. So I'm going up very, very slowly to find the situation where it will be just about cut the bottom. Here I select the edge node, the group node, where I select edges, include by edges, and unshare it. So I only select the open area. That's why I need it to clip it to so I will have all my collision, bottom of my collision, clipped. Then I, using the edges group, I do curve from edges node, and I have like continuous line. Then I do resample, then I do fuse, and I do resample specifically with a big length, so it will like curve around the corners, because I do not need it very precisely, but I do need to, like the shape of the mesh. Also here on top, at the same time, I'm adding normal attributes to my mesh, and I'm not doing it to vertices, I'm doing it to points, so you can see all the normals. And I also blur them pretty aggressively, and you will see in a moment why. So here I transfer my normals from the mesh onto the splines, onto the spline, and you can see now normals of the spline. And why I'm doing this is because I want this shape to be wider, and that's why I use the peak node, which and don't forget to uncheck recompute point normals, which moves the points in the direction of normal. And that's why I wanted to blur them as much as I could, because I knew that I have pretty sharp angles, and I wanted to make them as smooth as possible to begin with. So then I make it larger. I do a resample, and I do resample with subdivision curves, so it will be even smoother. Another smooth, because resample breaks the continuous line. Then smooth to make it even more smooth. And also, if you can see here, probably because of the which stage, I don't know which stage. Peak node, because peak went not just to the sides because of the normals, it went where the normals were pointing. So after this, when I have this shape, I use the point node, point expression, and here there is like a standard. Let's do it. Oops. There is a standard expression in the point node, which is flatten bottom. That's what I want to do, but the only thing that I need to change, so it does each x value of each point is preserved, and for y value we do we delete everything except get b box mean in y. So actually we don't need max, but it will work anyways, and we preserve z. So if we do this, you can see that all the points are getting aligned because of get b box. It means the minimal value of the whole thing. So we just basically flatten it. There are different ways of doing this, but this is just one of the ways. After this, I'm cleaning all my attributes, and I do a sweep with ribbon, a really wide ribbon, to have like a cut-out shape of my the whole podium thing. And then I do polyfill with a triangular fan to have it closed shape. And I use my landscape here, which I separated in a separate node in here. And so I bring it here with the object merge node, which is object merge. And that's why we do out underscore and the name, so we'll be able to find it later, like out landscape. The other way to do this is, if you're close to your null, you can do it like this. You can have this one selected. You can just press my mouse button on the bottom of it and just grab and drag it over here, and it will be added to your merge node. Okay, anyway, so now we have our ribbon and we have our landscape. And I do put it a little bit lower, so the roots will not be just going right to the landscape. The roots will go a little bit deep into the landscape. That's why I just lowered it for 20 centimeters. And I use a Boolean node to cut my my shape of my podium out of the landscape. And so this will be my the base of where I want my roots to end up with. And that's why here we have our starting point for the roots, and I use the ray node to bring them all down. And again, I use ray mode in a minimal distance method, and you can see all of them are gathered as close to the landscape as possible. Then I do and it's like it's too regular. If we just keep it this way, they will be just going straight down, and there will be no natural variety. So let's bring it more variety. So let's do point jitter. But then again, if you do point jitter, and it's actually pretty big jitter, you see that they are starting to escape, and they're gonna end up under our podium thing. So we need to bring them back to our landscape, and we need them to stick to the landscape. And this is where relax node is very convenient, because it brings, you can see, like I can do relax in 3D space, and also if I bring my landscape into the second output, it shows, you can see on the bottom, surface to adhere to. So all my points will stick to my landscape, and they will not under the podium anymore. But then again, it was too regular, and so I did another point jitter, but now it's kind of a little bit smaller because the points are already where I wanted them, and I did another relax, and you can see that way less points are affected this time. So actually these two nodes, and I might as well mark them with green, because those will be one of the easiest ways to change the shape of our roots, and I'll show it a little bit later when I'm done explaining this. So we ended up with our points, and you can see that actually one of the points, because of the jitter, it escaped on the other side of the Buddha head, even though we started from the one side. And after this, we do attribute wrangle, where we will. So let's get back for a second. So we had our points here. We gave them ID attribute, index ID, and we scaled them down a little bit from the shape scale. Here, I am putting them, when they're already down and they're already attached to the landscape, I'm making them even smaller, just a little bit smaller. I mean, actually, yes, it's a little bit smaller. So I'm making them even smaller, but they still keep their original IDs from here, and that's how we're gonna connect them. So then we merge our top points and our bottom points, and we use add node. We do it by group and add by attribute, and attribute is index, and that's why each point which was here and then end up somewhere in a landscape, it still remembers its ID, and so now we can connect them by ID. And let's see if we can do curve view. No, p-scale attribute. It still shows class. Oh my god. That's very inconvenient because I do not need class all the time. I need p-scale now to demonstrate the results. Oh well. Okay, so now we have our splines. Then I do resample to have more points, because with add we just had like just 2 points. And also what I want to do here is I want to attach the top of the points closer, bring them closer to our head shape. And that's, oh no, hold on a second. I want to bring them closer to our original spline. So I want them to kind of not just stick out of the spline. I want the top part of the roots kind of follow the spline for a little bit, at least in the beginning. And that's what I'm doing here. And it looks super ugly, but just bear with me. So our points in attach group, and I use the range. So I use like 6 top points, and I only use them to attach here. And after we're done with this, now we need to process all of them with the same for loop with feedback that we already did a couple of times. And this is where it starts, and this is the whole thing, the whole time processing all of those splines at the same time, and we do it 10 times. So let's go to the iteration 0 and see what are we doing here. So first we get all our splines in, and I will reset the cached path. So this is what we started from here. Right, then we do resample with subdivision curves and 1 meter size. Then I select by range, I select only top, like first 3 points of each spline. Again, don't forget affect disconnected geometry separately, or otherwise it will just affect the first spline, not all of them. So I have my tops selected. Then I do point jitter, except ends, which I do not have yet. So, but ends will be created later. So right now in this first iteration, this one group, exclamation point with the group name means that affect everything but this. So we are jittering all of those points. Then we do resample again, and this time we make a resample with a very small length. So here we had like a big distance between points, and here we had long distance, and here we have very, very small distance, and you can see they're already much smoother. Then here I use my collision, which is single shape, single mesh. And by the way, this is one of the reasons why it's super important to make a single mesh out of all of your collisions, because if you have multiple meshes, even if they're like joined together, like merged together, this does not work correctly. This will not work 100% of time. So just remesh them using VDB from polygons. So we select whatever is inside of our head. That's why we use points. I name it cross. I always prefer to name groups, giving them names that I understand what I'm doing. even though it takes a few seconds to just, type the name of the group. So I'm using the group by bounding region by bounding object. And you can see that there are points that are trapped inside of our mesh. So I select them here on this stage. And on the next step, I ray them. I use the ray node with the same collision and with minimal distance. And I only affect cross points, the ones that are inside. I am trying to bring them out. You can see that they are snapped out of the mesh. And I also use lift to kind of raise them above the surface a little bit to make sure that they will be out. And in a few iterations, absolutely most of them, the ones that are trapped inside, are getting out. Sometimes it doesn't work, but in absolute most cases, it works. So after I brought what I could out of this shape, I select ends, so the points that are closest to the spline, that were attached to the spline, and I use ray on them. Hold on. Okay, ends. I'm affecting everything but ends in this case. And I also use a very small scale. So this effect is a very small. They are moving a little bit closer to the shape, to our head, but not too much. Like you can see, if I increase the scale, they are jumping to their to the closest position possible. But with a smaller scale, they're just moving a little bit. But again, with every iteration, it does affect shapes in the end. Then I select bottoms, so very last point of each shape, and I ray them. In this case, I ray them to my landscape, so they will not be sticking out of it. And also remember that the landscape is a little bit lower than actual landscape. So even though it looks like it just barely touches the landscape, actually the real landscape, it will be over here. So we will be safe with the roots, sticking out of the landscape as if they are floating in the air. So I'm bringing the ends to the landscape. Then I do another resample to get rid of those big gaps between points. Again, resample is with small scale. Then I use fix node, and the fix node here, I want to affect every shape, every spline, but all those splines are. And also here, I just not forget, I use curve view attribute. So now, again, I'm assigning each point of each spline the curve view attribute from 0 to 1, so from the beginning to the end, and I'm only affecting the beginnings. I only want to affect beginnings only when they are attached to their parent shape. So here, what I do, I make a group by curve view attribute for points, by curve view attribute where curve view attribute is less than 0.1. So I'm affecting 10% top of each spline here, because I want them not to participate in detangle node later. And so if we do just this, then when everything goes into detangle node, you can see that they are being affected too, because detangle, which is it needs previous position, and I just usually use P as a position of each point. And you'll also see that there is there are parameters that are showing the detangle node not to affect. So not to affect the points that have this parameter to self collisions and this parameter for disabled collisions. And so what I'm doing here, after I selected my groups that are closest to my roots, I convert those, I create attribute, so attribute create node, this one. I use this group that I just created. I affect only the group. I create attribute, just copy it from here. So I create attribute and I give it value of 1, because by default this value is 0 because this attribute doesn't exist. So I create it here for fix group, and here I create disable external for the same fix group. So after this, some of our points, you can see it here, disable self, disable external. Some of our points have attribute, have 1 in those attributes. And then when we stick this into detangle, they will not be affected. So let's demonstrate again. You see that they are straight, the beginning of each spline. And into detangle here, I use the head itself, and I also bring my main roots, which we created over here, because I use them as detangle bases. So if there are splines very close to the roots, except the ones that are very close to them, very close to them, because we want them to be inside. We want them to actually go in, all the way in. So we detangle our splines from each other and from our collisions. And after this, we do remesh again, and this time I use 0.3. And so this loop, so this is the first iteration of the loop. Actually, it's a 0 iteration. It's how it comes in. And then after 10 iterations, you can see that the splines are moving closer, getting detangled from each other, so they're not crisscrossing anymore, at least mostly. And overall, to me, the number 10 iterations looked like a good trade-off between speed and effectiveness. And so we do this to every node, to every spline, and now we have our splines. And if we merge them with our original splines, our 4 main splines, if we merge them and stick them into sweep node with just value of like some radius, you can see that that they are actually respecting peak scale attribute that we were lowering, and you can see that the roots are thicker in the top and the thinner at the bottom. And let's look into point jitter attribute, the one that I said will affect it the largest. And also I will bring here my collision just to see what it does together with when we use the head, just to see what's going on. Let's say just use just this. Oh my god, I hate this. So yeah, you see that it actually wraps around the shape pretty nicely, not crisscrossing it. How do I turn off? Oh. All right, maybe this will help. Maybe now we can use p-scale instead. It will not show anything. All right. So if we play with our point jitter here, which will be the main way of bringing chaos in here, and you will see that it changes the shape pretty quickly. So I'm just changing the seed of our jitter. I can also change the scale to bring points further away from each other. This is all up to which look you're going for. So yeah, absolutely up to the specific need of the scene. Well, let's say we're going to use this. So you can see we already have our shape more or less done. And again, depending on the situation you are in, you might want to have most of those attributes different. Like maybe you will need resamples different every time. By the way, this resample doesn't make sense because it will be on the next loop. It will be changed into 1 right here. Right. Okay, so now we have our 2 sets of splines, our main trunks, main roots, and secondary roots. Let's bring it even further. And so here I have from my main roots, I drag another curve So I'm just carving them, just the value that I thought looks good. So in this case with this, I don't even bother about randomness right now. And now I'm using the lower part of my main roots and my secondary roots, bring them together, assign to them class attribute, which here actually would be, I always forget how to turn it on here, which this one, okay. So see, they all have different class right now, and here we do random again, just depends on your taste. Let's do, so we select some amount of points. This will be our connector pieces. So okay, let's do this. Then we blast everything but them, and we remove the splines, only keeping points. And those points, by the way, still remember their p-scale attribute. So no matter if they were from the main roots or from the secondary roots, they still know their p-scale at the point of connection. Here I do, let's see, let's put an attribute. Here I add n normal attribute, so I make all the normals to look right. So one, and actually up I think up doesn't matter here, but just whatever. So I do this. Yeah, I think up doesn't work, because then I do scatter and align node, which requires normal attribute. That's why we need to create it beforehand. What it does, it assigns, usually it works on something like, let's do, I don't know, sphere. It's very, very powerful node. And let's do scatter and align. If you need to create a bunch of points on some object, and those points would be pointing from the object, let's say by number of points. So we create a lot of points on this sphere, and all of those points will be using the underlying normal of the shape. So like, let's say if you want to have a head and have a hair sticking at the 90-degree angle from the head, that's what you do. You scatter and align. And then here you can do some random values. So if you need to scatter something on something and it will look away from the surface, that's what you use. A very, very powerful node. But here we want just to assign, as you can see, we not just scatter points on geometry surface, because we do not have surface, we just have points. But here we want to add attribute to existing point cloud. So we have our point cloud, we have our normals that I just added before, and now we are assigning we are assigning random normal direction, but it's not really random. It's random only to compare with the original n that we have. And now why we're actually doing this. So here I have a line, and I want to scatter a bunch of those lines on those points. So after I did scatter and align, and you will see better what's happening in a moment. Then I delete my p-scale, because I just want those lines, because if we keep p-scale, every line going into the point will have a p-scale of that point, so it will be shorter or longer. Now I just wanted the lines, the same 3-meter lines everywhere, and that's why I deleted p-scale attribute. So here you can see when I do copy to points node, and I bring this to my points, scatter and align allows me. So by default, they will be like this. So each one of them, so it goes, that's why I said that up probably is not necessary, because it goes up is by default 90 degrees from normal. So if normal points right and my line points up, then when it's scattered, it will point up on those on all of those points. But then here I can do a little bit of random cone, and so my points will be going randomly a little varied direction. And also what we need to do here is we need to transfer attribute to them, all of the attributes, including our p-scale, because now we need it. And we start for each loop. And what do we do here? We go over every point, every line. We find its end. So its end, like its top part, not where it's attached, because the bottom part is where it was attached to our point. The top part is free right now. But what we want to do, we want to attach it. So we start this line from some root, from some point on some root, secondary or primary, and we want to attach it to some other root, not the one that it was started from. We want to make these connectors between roots. So first what we want to do is we want to find the end, the point that will be connected. Good, we found it. Now what we want to do is we want to delete our, so our splines are here. By the way, why it's not attached to its all right, because I saw that it wasn't, for some reason it wasn't attached to its point. Okay. Okay, so all of them are attached. I guess here let's start from the beginning and reset cache. Okay, this is my spline. Yes, okay, it is indeed attached to, as you can see in this example, it was probably looking at the end of the loop. It is attached to its root. So it is attached to one root, and now we want to attach it to some other root. And that's why we need to find which root it belongs to initially and remove it inside of this loop. So that's what we do here. We take our line, and we see that it does have class attribute. Here we delete the top point, the one that is not attached, because we only need the bottom point, because the bottom point will tell us by class which root it started from. And we take its class attribute over here, because that was the spline it was attached to, and we promote it here by attribute promote. We promote it to detail attribute, and we keep the name class. And now you see that it showed up here. So in this loop, we take a spline, we remove its top part and only keep the bottom part, because here we transferred attribute, including our class attribute from our points, pscale and class. You see that all the classes are different here, and so in our node here, our point here, we promote attribute, and now we have a detail attribute which is accessible from other nodes, because normally the attributes without spare input, normally attributes are not accessible, but this is the way to make other nodes to know about what's going on here. And so we take all of our roots and we go to the group node, and in group node we use this formula: at class, which is equals to detail point class. So point class is the name of our node. You can see it here, just like we did before with for each loop. So our name of the node is point class. Our attribute, our detail attribute, is class, and it's 0, and it's also like one dimension. So on the first member of one-dimensional attributes, it's always 0. So just as we did before when we were doing randomness, we use this formula: detail, the address, the name of the node, the name of the attribute, and dimension of the attribute. And here, those little like, it's not a quote mark, it's a mark that is on a tilde button, the one that's on the escape button. So we do this to extract from here the number of class, and here we make it, as you can see, those points, all the points that have class attribute 0 are selected right now, and then we remove them. And that's how we remove our parent spline from the pool of the splines to be attached to. And when we do array node for our endpoint from here, it will be attached only to any other spline, which is minimal distance spline. And if we do this, you will see all the roots. So it will be attached, all the roots but the one that we deleted. So it will be attached to any other root, whereas which one is nearest. And we do this for all 800 of them. And now you see this. So this is what we have in the end. And all of them attached to everywhere. Let's do a merge and actually demonstrate this. So all of them are interconnected between each other. And it's a mess right now, and we will deal with it in a moment. So when we're done with this, now those are just straight lines, which is not what we want. So we do resample, just like with some small value. And let's get rid of attribute. Then we clean everything from them except curve view and except p-scale. So remove attributes, asterisk means remove everything but this too. And we do a remap. So yeah, with this resample, we actually also created curve view attribute for each one of them. So each one of them now has its own curve view from 0, let's take this one, from 0 to 1, from 0 to 1, all of them. And after we clean them, we still remember p-scale from their parent, and now we have a curve view from each one of them, like their individual ones. When we do attribute remap, as we did before with our thick roots, here what we do, we take the individual curve view attribute and I create a local p-scale for each one of them. So now if you look at the point attributes, you see that they have p-scale, a local p-scale. And local p-scale depends on a curve view. And unfortunately I cannot demonstrate it because of this weird bug, and I really do not want to restart Houdini. Oh no, oh look, oh my god, it works. Okay, so we take curve view, and because of this curve that I created, now it's creating p-scale from 0.2 to 0.7, and so it will be larger on the sides, and you can see it by color. The hotter the color is, the warmer the color is, the bigger the attribute is. So it's larger on the ends and it's smaller in the middle. And again, you can regulate it. You can make it like even smaller. But let's keep for now. Let's keep the values that I came up with. And so now each individually has like a curve on it, and it also each one remembers its p-scale coming from the parent. And so what we do here in this attribute wrangle is, let's try to use p-scale instead. Okay, the p-scale is not that pronounced, but you will see that it does make difference. So what we do here is we assign to p-scale of every point the p-scale of the parent. So like we are reassigning p-scale because we use it here. So we multiply our p-scale by local p-scale. So let's say if this little line was created in the bottom of the roots where the roots are thinner, its p-scale will be smaller. But now multiplied by its local p-scale, so it will be smaller, the whole thing, but also it will be even smaller in the middle because we use local p-scale. And let's demonstrate it by sweep node. And again, let's reuse round tube and some larger value. And you see that here we have in the bottom the tubes that are thinner in general, and on the top they are in general thicker because they work with larger scale roots. So this is what we have so far. All right, now we do not want to live with those straight lines. We need to zigzag them and make them look more natural, and also we need to detangle them and work with collisions. So basically this is very similar to what we did in here with the secondary roots, but let's still work through them. And this is again a feedback with loop cycle, so it will do as many operations as we want it to. And in this case I just I think that 10 is good. 10 is default, and I think it's good enough. So let's see what we're doing here. Reset. So we are on our first loop. First we do resample to small value, nothing else, just have smaller value. Then we select our ends, which is last 2 points, because those are points where they are attached to their roots. We do not want to do really nothing to them, because we just want them to peacefully go into their parent roots and stay there. Then that's why when we do point jitter, we do it to everything except those ends. Also, when we do smooth, we do the same. We do this. We apply smooth to the whole spline, but constraint points are ends. So our ends remain where they are, no matter what's happening here. Then we do another resample with much smaller fraction, and you can see that the lines actually we can also do subdivision curves here to make them even a little bit smoother. Then again, just like before, we create a cross group, the ones that are trapped inside of collisions. And because we worked with our lines beforehand, and we made sure that at least absolutely most of them will be out of the collisions, we can be fairly sure that the ends will be out of the collisions, where they start and where they end, but the middles, as you can see, can be inside. The way of avoiding this would be, again, our points trapped underneath, and while our head is not deep enough, they kind of thought that it's fine to be under it. But I guess we could, in the beginning, we could just like take the sides, the perimeter of our head collision, and like move those perimeter points, move them far down. So the whole thing would be much deeper. Then even with jitter, the points will be trapped inside and they will be pushed out. But yeah, let's just agree that let's say that it's fine. So then we push them out of the collision, which will not work for most of them because you can see they just stretched out. But yeah, it happens sometimes. We'll discuss it later. What can be done about this? Then we do another resample, and yeah, unfortunately, these are going to be stained like this. We're going to do another resample, again, small one. Then we do fix, like before, for the ends. Just again, because we did resamples, we could lose our... Actually, it's the same as ends. We could reuse the ends, but we will have to redo them here, because when we do resamples and when the points are moving, resample will diffuse the attribute. They will not be to last anymore. That's why we need to reintroduce them again. And after this, we do, again, disable self and disable external, just like we did before, and then we do detangle. And for detangle, for the collision, we use collision. And we repeat this 10 times, and let's see if it will help our points. Most likely it will not. And it did not, so they're still trapped inside of collision. Okay, then we clean them, and then when we merge them, now we have our roots. And if we do sweep, you can see all our roots with connectors. And now would be good point to see like what we can do, for instance, with attribute remap. Like if we do them from 1 to 2.2, so now there will be, the connectors will be thicker at the points where they are attached, as you can see here. Or we can do 0.1 here, but I would not recommend to make them too thin. Yeah, and unfortunately, yeah, this one's inside are they're not gonna work. Maybe if there'll be like cracks, it would make some sense. But yeah, not in general. And what can be done here is where I lost it. Yeah, here. So I also do some smoothing for the whole thing. And also in this last sweep, I do end caps with grid. So when I do smoothing, it will smooth. You can see here that all of them now have rounded edges. When I do smoothing, it will smooth the whole things. It will not just smooth the middle of the shapes and leave their edges untouched. And then we just blow end caps because we do not need them. actually upload them here. Like if this is something that will be your final shape, because for instance it will be really easy to texture, and if it will be good enough as the final point, then yeah, here you can just do add UVs, then add textile density, so they will be the same size everywhere. And yeah, this can be, depending on the circumstances and depending on what the goal is, that can be more or less endpoint. And so if I bring our collision and our landscape and our everything, oops, the color is too dark. I just applied some random color to be able to easier tell shapes from each other. So yeah, if this is what is good enough, which is kind of is not. Yeah, see the some roots are trapped under. Let's see if we can change this with our point jitter. Maybe we can fix it so it will not be that bad. Let's say a bit less of scale, so they will not travel that far. Yeah, some of them will be still trapped in, but then again, maybe there are some cracks, and maybe there will be, like, you can, you know, explain this with some reasoning. So basically the main way to adjust the shape would be adjusting P scale in the first case or in the second one. Again, it just trial and error, and I think to me it's kind of, it works quick enough. So yeah, see here it didn't work perfectly, the trapped point. Maybe if you add more iterations here, it will get out. But then again, when you find the shape that you can feel is looks like something that might work, then you might say, well, okay, now let's try to increase number of iterations. Let's maybe try to decrease something. So yeah, it's a matter of taste and a matter of the task given at this point. Let's find some. Okay, now it's getting smaller, and now it's getting closer and closer to the head. Let's find some interesting shape with least amount of crisscrossing. Yeah, kind of stairs, kind of too attacked here, I guess. What can also be done, technically, we can take those like for instance right here, when they first were introduced. Now we can, in theory, just in our circumstances, we know that this they need to be moved kind of left. So maybe we can just go like -5 in their position, and then try to jitter them and relax them, and maybe they will be then more sticking to the left side of our head. Let's see what's going to happen. Yeah, like you see that they went further, and now we have way less roots sticking to this side. Maybe -10. Let's see what's going to happen. What I'm trying to say is that there is no really right way to do this. This is just one of the ways it can be done, and yeah, you can see that this can be, this can be working. But let's bring it to the original version. I mean, I will not even be able to reproduce the original version if I remembered which values I had for my jitter. In here I could, but I don't remember. So this is something that yeah, again, I was just like clicking randomly, and this is the shape that I've got, and there was not too much. Actually, if I close my block out, yeah, actually there is not even it's not even crisscrossing. So I deemed it to be good enough because yeah, I decide here, and I like this this arch shape. That's why I kept this version. But yeah, you just try around and see, I guess. Let's find some shape. Okay, I deem this one good enough as of right now, I guess. Nah, no. Let's move a little bit to the left. -7. Yeah, all right. Yeah, let's stick with this. I also like this one, this arch over here. Right. So the main shape is done here. What can we do here? So here, in this case, we have just tubes, but tubes are no real fun, not super interesting. So what else we can do? Instead of just round tube in here, we can do something more interesting. Let's create a sphere. Move the sphere to the right and make it smaller. Then merge it. Then boolean them together. Clip to have edge and to have like one continuous shape with the edge. Do the edge as I did before. I already showed how I'm doing this. Unshared edges. Curves from edges. Resample to make them smooth. Make them smoother. Make them match size so they will be in the center of the world, and make it a little bit bigger, and also rotate 90 degrees just because I know that it needs to be like a vertical facing Z direction to be used in sweep node. And so I use this construction as the secondary input of the sweep node. And here you see that by default it actually takes a second input cross section. So now instead of using the round tube as our cross section, we use this roundish thing, and I put it into sweep. And also to add some fun, I also do some twists per edge, so partial twists per edge, and you see that they are all twisted, so it adds kind of this this old gnarly look. It also adds, now also our caps are visible. So maybe in this case, instead of using grid, we can use like single polygon. But again, nah, let's do grid and maybe just make it smaller scale. So it will be not that sticking. But also this sticking can add visual variety later. So again, it's just a question of what you're looking for. Well, then when we're done with our, well, let's say we decided to use this more gnarly look. Then we add our p-scale, transfer p-scale attribute from our splines, which each one of them had it, to our mesh. So we just transfer attribute. And from here we do subdivide just to make it, just make the shape a little bit like it adds a little bit of smoothness to it. And from here we do VDB from polygons. Again, we turn it into voxels. And it takes a second to work. Yeah, you see that those caps added some sort of visual variety. Then we do smoothing here. And we convert them to VDBs. We convert them from VDBs to polygons again with a little isovasive. So by the end, we will receive almost our shape. Isovasive is usually needed because it gets a little bit smaller. So then now they are kind of melted together. They're not those like tubes sticking out of each other any longer. Now they're melted. Now they're looking way more natural. But of course, if you got to this point from here, like here, it would be a fairly easy job. Like it's not such a huge mesh, I guess. Fairly easy job to texture, and it can be textured with like a tileable texture. Here we past that point. Even if we transfer attributes, like transfer UVs from there to here, it would be as well, at least in my opinion, it will be as good as just making new UVs, because it's just too far gone from from being easily texturable. Also, if you want those sides, those borders between roots to be like even smoother, you can increase the smooth iterations, and then it will make mesh a little bit smaller, and then you will have to like increase as evasive, or maybe just knowing about this from the beginning, make each root a little bit thicker, so then you can compensate for this. Although it kind of didn't lose. No, it did lose. You can see that it did lose the shape, the value, and also it lost this gnarliness. But now it's more looks more natural in those connections. Looks like more like this spider web. So it's just again a question of what's your goal, what's the visual goal you're going for, or maybe you just need to increase. In this attribute remap, you just need to go not from 0.7, maybe you just need to go from 1, and then it will be thicker in the beginning and more smooth in here. So right, let's look what we can do more to add more details. From here, from our final shape, I am adding mask by ambient occlusion, mask by feature. So I'm using ambient occlusion of the mesh as mask, and you will see the result in a second. All those operations actually take a lot of time, so you better choose the shape over here where it was much easier to see what is going on. And let's see our mask. Okay, mask is on. So now you see that the colder the value, the more ambient occlusion there is. And what we're gonna do here is we're gonna make a group named delete, very speaky name, of everything that has mask less than 0.95. So everything that is not sticking out is going to be deleted. Also, you can see that the trunk up top here is getting a lot of like it's very, very exposed. So I'm gonna use the second delete node in a mode union with existing, and here I'm adding a box going from the very top, and I'm just arbitrary deciding where I want to cut off this selection. And by the way, if you want to use to do this with the mouse, stuff like this, you stick in the middle mouse button, and then you have these scales, and you can adjust it. It just works pretty slow right now because it's a huge mesh, and also I guess I'm recording, it doesn't help either. Yeah, now it's just jumped. What, it was 5? Now it was something like 15. Oh no. And you can see now it's crawling. 30. 26. Yeah, let's stop with this. Let's no, actually 28. I just want to get out of this. Yeah, get to the roots when the roots start, and then I delete everything that was selected. So I'm only left with those exposed parts of the roots and trunks over here. And here I do scatter and align, which we already discussed before. But now I have a surface, so I actually can scatter my points on this surface, and that's what I use the default value. And I'm scattering 3000 points, and target forward vector is y. And what I want to scatter there is, so I took the sphere and I transformed it into this sausage shape, and then I bent it, and then I transformed it by 90 degrees. And 90 degrees because just because I knew how it's gonna scatter. So I'm adding this like a little snakes, and you can see here I'm just merging it just to visualize for myself what's going on here. So you can see them sticking out like little it's rather a question of like adding some detail variety. You can see that there are like some small holes in our example, and some small like details on top, and that's what I was trying to replicate. And while here, after this scatter and align node, I do attribute transfer, and I transfer attributes from here. So from our, after our sweep, remember we did this attribute transfer and we transferred p-scale. So now if the roots are thinner, they have smaller p-scale. If they're thicker, they have bigger p-scale, and p-scale is a scale of the objects. And so we transfer this attribute to our new created points. And so when we scatter and align, they actually respect this p-scale, and they make these details larger or smaller depending on it. So this is how it works. So this is how it looks right now. And again, you can vary them, and they are like sticking out, which is fine in my opinion. And we also, after we scatter them, we use mountain node to add them, to make them less less uniform, to add some details to them. And what we do here is we convert them to voxels again with this size. And remember when we had our initial roots voxelized, so the size actually the size can be the same, but also, so when we voxelized our little wormies, now we need to combine two shapes. Like we need to add wormies to our main root. So we use VDB combine node in SDF union node. And here resample goes B to match A. So this is our A, and this is our, so our wormies are our A, which is size this, and our main roots have this size. And so here it will rescale it, unless we do this one as 0.25. And the smaller it is, the more details it will retain. So maybe it will make sense. Again, depends on the scale of your mesh. So this is how it's connected. But what we also can do is we can do from here, when we did our mask, we can add delete node here. But instead of deleting, instead of selecting only the deep parts of the mesh, we do this otherwise. We select everything that is exposed, super exposed. And so we delete this, and then we remained with we left with like deeper parts, with more occluded parts. And after this we delete the most deep parts, because they're mostly gonna be like even invisible. So that's why I decided to kill them too. Actually, no, I actually didn't even kill them. Well, let's kill them. Let's see. And then we scatter and align on them absolutely the same way. Some points. This time 7,000 points. Yeah, and I did uncheck p-scale attribute here. So again, we have a little sphere. Remesh it. Why did I remesh it? I actually have no idea, because it wasn't necessary. And transform into like little I don't know, cylinder-ish type thing, drop. So we have our points, and we place them onto our roots, and let's see how it looks together. So it's going to be those little holes, those little pits, and they're mostly focused, they're mostly scattered in like deeper sides of the mesh, not on the most exposed sides, more like in the corners. And so that's how it's gonna look. They're gonna be like little pits here and there, but not on the open exposed sides of the mesh. So after we scattered them, once again we do mountain node to make them a little bit more uneven, and we do again VDB from polygon, so we voxelize them in a second. And the size is, what it was, 0.25. Well, let's keep it at 1. And so we had our combined little wormies and roots, and now we combine these two. But in this case, we do SDF difference, and B matches to A. So now no matter what size these guys are, they're gonna be brought up to the size of our main roots. And we can do smoothing, and we can do convert VDB finally to our to have our polygons. And with smoothing, you can see that the effect is very, not even very visible, I guess. We can undo smoothing, and again, this is what you, depends on what look you're going for. What is the goal, and you can do many things like that, adding details like that. But let's say that I want to be smooth just a little bit, and at this point, I add a little bit of mountain on top of it to make the whole surface of the roots a little bit uneven, and that's why I use Worley cellular noise pattern and a little bit of fractal noise. So now the whole thing is kind of has this uneven look of bark, even though kind of smooth bark. And this is the case where this mesh, pretty very high poly, can be used, I guess, as a like high poly if we decide to unwrap everything. Now, unwrapping this is, of course, a nightmare. And again, depending on the project you're working on, you might unwrap it and bake it. And maybe I will cover it in the next tutorial because this is now almost 2 hours. Again, if there will be a question, or if the artist that asked me initially will ask for this. So we can talk, actually, I do have later here UV in it and packing UVs into UDIMs and stuff. But if it's not like for the game, it can be just not even UV'd, and you can use triplanar mapping texture materials in Unreal with like mixing materials by noise, which I did once because it wasn't for the game. It didn't matter for game. Triplanar mapping, it's super expensive, so it will not fly. So at this point, I did again for some reason. Actually, I don't even know why I did this. Again, VDB from polygons to smooth the whole surface once again, and then again convert to VDB. So each time you do VDB from polygons and then convert to back to polygons, it smoothes it out and makes it more, yeah, I guess more natural. And after this, I just deleted small parts, which are like, there might be some meshes that are after VDBs, like if the roots were super thin, they might be broken and like separated from the main mesh. So I just usually just run through it when I do, especially when I do VDB remeshing. So I delete small parts if there will be some like sticking out little roots. And after this, I do a couple of poly-reduced nodes, which are super slow. And one note about here, like it's usually better practice, like from experience and from, again, it's like kind of common knowledge that you better like do poly-reduce by 50% like 3 times than just try to extract 5% mesh in one operation. So usually it's better to chain them one after another. The results are usually better. So, and I saw it myself. I guess the way that it analyzes the mesh just, yeah, makes it better. So let's go to the very end of this. Oh, and also the tree. I forgot to discuss the tree. We'll do it in a minute. So yeah, the first one is always the longest. Now see, we only have only million. So 1.7 million triangles. Also, poly-reduce is a very good node in Houdini. It works really well. Creates triangles in the end, which we need because we do not need quads here. Because in the end of the day, everything in Unreal is triangle, and we do not need to animate this mesh. That's why triangles will absolutely work for us in this case. And after the third one, I would deem it good to go. And you can see it still holds mostly its shape. It's 400,000 polys, which is a lot. But again, if you want to use nanite, it's not that bad. It will be not such a nightmare for auto UV to work through. Yeah, and maybe it can be, you know, run through another round of poly-reducing. But anyways, after this, I usually do a practice of making a as shop material path node to actually apply the name of the material that I want to see here in Unreal. Then I do cleaning, except not removing UVs, which I don't have in this case, but normally I would have, and short material path. And then I do normal, and for normals, I always do, I mean, except for the cases where it's like for natural objects, pretty much always, cusp angle as much as possible, 180, to make it as smooth as possible. And then triangulate. Triangulate is not necessary here because it's already triangulated. And then when I export, a couple of notes here. If you put the final name that you want in here, and then in output file, so this is the path of the working file. This is then the folder inside of this path that I want to put my FBX into. And then after slash, I do $OS, which means that the file name will be this. You don't even need to add FBX here because it will be FBX by default. So then I will have my output file will have this name in this folder, in the folder where the project is. Always uncheck export in ASCII because it just increases file size dramatically and absolutely have no reason. We just need binary file. I mean, if you do need like a text file, but probably you don't. Convert units, so we will make sure that it will have centimeters in Unreal, and you do not need to scale it in Unreal. And also compute smoothing groups, so your normals will be included into your mesh. And then Unreal will not complain that the smoothing groups are missing. So yeah, and then you just export, and that's your mesh. Now let's talk for a few minutes about the tree side of it. So let's say I want it to be a tree. Let's say my task is to actually make a tree out of it, and making, and you know, again, if it's a game, then the character will be here. They will not see the tree. So the tree can be done more like in more traditional way, which Houdini does, or like not even in Houdini. So let's look back into our very first meshes, very first splines that we exported and processed. And if you remember, even when we processed them, like we stuck them to the head and everything, we did not touch the top part. That's why I can go like in the beginning when I created our splines, and when we like glued them together with soft transform, now I can use like the top spline. That's why I made it a little bit longer. I can use it as the base for my tree. And so from here, I stick everything into Blast, and I deleted the third polygon. And why third? Because when I'm here, I can turn on my polygons and I can see that the spline that I want is number 3, the longest one. So that's why I blast here everything but it. And I stick it into Trint running generator mode. Note, I think it's labs. So yeah, it will not work for those who has apprentice license, because I don't think that labs series of nodes work with it. But then again, you will have your spline to base your tree on. But let's say you do have labs nodes, so you can create a tree. So first thing, like if we do this, you can see that the tree, even if we stick our spline in, the tree immediately jumps to the center, to the middle of the coordinates. We'll deal with it later. But from here, like I did add some basic roots. Actually, it's not even needed here. I think I actually copied this node from somewhere from some of my other projects. So this is definitely not necessary because we're not going to use the trunk at all. But you can see that the shape is following my spline. So then I add some branches, and knowing that in my cave, in this case, like my sun comes sort of from the right of the head, then I might as well use it as like a photosensitivity of plants, because they do grow toward the light. So I decided to use the phototropism to move my branches a little bit to the right. And then I create the secondary branches. This is like, I spent like a few minutes doing this. It's not thought through. It's not like final. It's just for demonstration. So this is my tree from the beginning of the coordinates, a little bit looking to the right. So now let's bring this tree to where it belongs, to actually our shape. So we have our spline here. So it needs to be here. What do? I create the anchor group. So the very first point of my spline, the starting point inverted, is my anchor. And in my tree, over here, when I just did my trunk, and you can see you can grab the trunk separately, and that's why I didn't. Technically, you can like go through all of them, and like you can use the previous levels, and so like by the end of the third branches, you can have your trunk and your first level of branches and your second level of branches. You can have all of them together. In some cases, you just need them separate. That's why I use delete previous level and then I manually assemble them together. And in this case, it helps me because I need to go to my trunk. And once again, as we did before, we need to find the basis of the trunk. And that I do this unshared edges points. This will be my anchor as well. And I call this group bottom. So when it's merged, I already know where is my center of my trunk. So then I have my anchor, which is the beginning of the spline, and then I use match size as we already did before, using groups to determine justifications, and I use bottom for the source, which is the tree itself, so what we're aligning, and we're aligning it to the spline, which has anchor group. So we're aligning bottom to anchor, and we don't do center, we do minimal in height. So yeah. And then after this, I blast my trunk, which is, if you can look here, all of them have branch ID, and every level has the second ID over here. And so if I do blast by add branch ID equals 0, it means that I'm blasting the trunk. Just to not use like a group or something. And so this is my tree. And these are my main roots. And so when I merge them, I can see that this is what I've got for the tree. Again, this is not a final product. It will not go anywhere. It's just for demonstration that you can actually use this like normally, you know, add vertex colors, add leaf cards or whatever else need to be added, and like make it behave like a normal tree. And so, but after this, like I'm satisfied with this, and I add, again, just for demonstration, material path, and I export it. I'm cleaning it, and I'm exporting it as a vines test tree. And here it is, imported in my scene. So that's it for today. I'm not gonna re-import the tree, although I guess did I save it? Yeah, that's it. If you have questions, ask. I actually was thinking about covering in like making the second part of this tutorial to cover the texturing, potential quick texturing in Painter, or triplanar texturing in Unreal. Actually, let me know in comments if it's needed, because yeah, triplanar can be so nice if you do not need it for the game. Yeah, let me know, and thank you for watching. Oh, also, again, let me know in the comments if you needed another tutorial about like a procedural spline, procedural plants like vines, you know, like more like I don't know, ivy or some whatever, like climbing vines to climb on this structure, because this is actually the case where it can be utilized in the shape of HDA inside of Unreal, because like vines can climb on whatever, and we can utilize like vertex points, vertex paint to work with this. So yeah, let me know, or we can do it in Houdini as well. Let me know if this is something that you would want me to cover. But on that note, thank you very much for watching. Have a great day.